How? Okay, after finish the sketch, I activate it and go to set up its parameters. Here you click the sketch. It will show you all the symbols as you see. The first one I set the crank. Number 2 as follows rod 1. It's rod 1, yeah. Rod 2. Let me see. Rod 2A and rod 3. Okay. Angle B is 20, 60, 180, 200, 300. Okay, the first one is D1. D1A. D1A, rod 1, rod 2A. And rod 3. And the angle B is here. Okay. Use regeneration. Okay, we have to set our analysis measure angle because the angle A is as small as it can be. This one is our design constraint, so we have to measure this angle. You can see the front tool here, and you can see this one is a normal direction, and here as you see, so we save as a future, and it's angle 1. Okay. Now we go to the application, the mechanism module. Here you need to set up a servo motor. Okay. Velocity is 10, constant 10. And you use analysis definition kinematics. We input 36 and 36, then you can get 360 and slightly snapshot. Okay, press OK. Here you can see the analysis angle. It should be the same as I measured previously, around 19 degrees. That's correct. The system didn't collapse or anything. Okay, here you have to set up the lens X, because here I can use here to use a system had run or 1 times, and the memory can get any information such as the Stokes distance, the maximum distance or minimum distance, or its velocity, acceleration. Here you can get to know on its load, impact, or anything else. But here I just want to know its velocity and position. No, just position. Okay. So LX. So here you select this one. Next one. Press OK. Press OK. This one's L. What's L is user defined. And make a difference. System I don't know, so you have to place slider position, and you select this one. Okay. Yes. Oh. As you see, the slider position is minus 482. So the but we don't know. We don't know its position. Here I have to modify to here. Okay. Yes. Here I want to inspect its point. So here I modify to here. Make brown again. Here you can see the results. The angle is around 19. But what we want to know is it's a stock L. So here you can see the M minus here it makes oh sorry. I make it wrong again. Okay. Oh, this one is correct. Because I last time I select wrong height, wrong direction. It's not magnitude. Is x direction. So the required is 200. Stock is 200 millimeter. Here just 152. It's not enough for our requirement. By the way, we want the angle as small as it can be. So yeah, I need to do some optimization step. Here you can save it first and go back to the standard module, and we use the sensitive because after mechanism this module, the system compute some mechanism results such as velocity, force, position, anything else. So now we go back to the standard list module to read this parameters, dimension, not dimension, but sometimes dimension, and the physical numbers, such as position, velocity, or acceleration or load. Here we can do analysis in standard module, and we have to do this one to understand its effect, because we want to use this physical material number to compute the right structure the optimization structure. So here I select motion analysis. What's motion? Mechanic has the other module, and here I use motion analysis. Motion analysis is for, related with the mechanics in this module. So select next. Here you see there are so many parameters. As you see, we had computed this parameter to be the physical numbers, or we want to use again in standard module. So I select all to use wrong. Here if you don't have a good computer, you must need some time to compute the results. Here you see I had done 70% in this case. So we continue waiting for the results. Okay. Here you can see the graph too. No, it's slider position. From here to here. Actually, this one is a I think I clip this one. We just care about its this max. This one is minima, and this one is L. It's the stock. Okay. The system will go to the 10. Time is 10, and then you will remain for a while around 147. And this curve is like an engine. You need some time to prepare or to work for the maximum value. And here you can see the angle. Okay. The minimum is 11, the maximum is around 19. So later we will use the formulation to make a average angle, and then we ask the system to compute the feasible structure for us. So here it's important, we have to select the result. Okay. You have to in here you have to remember every parameter's name, because in the later we will use this name to be a formulations to be a name in this relation formulation. So just you to use click here, and then next step I will use the analysis tool to do. Okay, here I stop and wait for the next analysis step.